Laplace rule. It is an important method for calculating the determinant of a square matrix. You have a square matrix, let's call it A. It should have n rows and n columns. It should be square matrix. It's the first row, the second row, and so forth. It has n rows and n columns. And you need to calculate determinant of this matrix. By the way, about the notations, element A, I, J, those indices are important. I, the first index, I, it is for the row. This element A, I, J is in ith row. And the second index is for the column. This jth element is for jth column. Now let's introduce notation. Let's introduce matrix. Let's start with matrix A1, 2. This matrix is obtained from matrix A. By crossing out the first row and the second column. Whatever is left will be matrix A1, 2. So if I cross out, so it's A1, 2, I cross out the first row and I cross out the second column. Whatever left is A1, 2. Now I can do it for any indices I and j between 1 and n. I can introduce this notation. Aij is obtained from A by crossing out the ith row and the jth column. Now let's write the Laplace rule. So I take this matrix A and I need to calculate its determinant. So I need to calculate determinant of my matrix A. And what I will do, I will choose any row or column. Doesn't matter which one. But when you use a Laplace rule to calculate determinant by hand, normally you choose the row or column with the most zero entries in it. So I choose any row or column. Suppose I have chosen ith row. This one is taken and frozen. I take ith row, then this determinant is equal to this sum. I do summation with respect to the column index, jth goes from 1 to n, minus 1 is raised to the power I plus j. It's important to keep here I plus j. A is frozen, j is moving from 1 to n. Then I take element at ith row, jth column, and multiply with the determinant of the matrix aij. That's the formula for the determinant when I have chosen ith row. Or I can do the same calculation with jth column. If I if I choose jth column, then my determinant can be calculated as this sum. Now I is moving from 1 to n, and the rest basically looks exactly the same. And that's the formula for the determinant. And it's called Laplace rule. It's important rule because it is easy to program. The determinant on the right here, on the right of equal sign, they are determinant of matrices with n minus 1 rows and n minus 1 columns. You can recursively apply this procedure and calculate any matrix if you know how to calculate determinant of 2 by 2 matrices, for example. And it's easy to program. You just need to do recursive programming, and program for the determinant is easy to write. And that's all. Thank you for watching.